Welcome to the deep dive. Today, we're shining a light, maybe ironically, on a growing environmental concern in our cities: light pollution.
Hmm.
It's not just about, missing the stars. It seems to have some pretty far-reaching consequences we're going to explore.
That's right. And we'll be digging into how we're using some pretty cool high-tech tools, remote sensing, to keep tabs on this often invisible pollutant.
Okay.
Our deep dive today, it sort of pulls together a really comprehensive look at how satellites and aerial photography are helping us get a handle on urban light pollution.
So the mission today is to really understand the spatial and temporal side of it, where it is, when it happened.
Exactly. How it spreads across our cities, how it changes over time.
And crucially, what are the actual real-world impacts of all this extra artificial light?
Precisely. We're not just looking at what it is, but, why it's a problem and what the implications are for our world.
Okay, let's unpack this then. When we talk about light pollution, what exactly are we talking about? It sounds simple, but I know there are different flavors of it, right?
Yeah, absolutely. Light pollution, at its core, is just how our artificial lights mess with the natural outdoor light levels.
Hmm.
But you're right, it's not just one thing. It shows up in several distinct ways.
Okay.
Think about sky glow, for instance.
Sky glow, right. That's that kind of hazy, orangey glow you see hanging over cities at night. Makes it hard to see individual stars.
Exactly. It's like the whole night sky is just lit up. It's caused by all that artificial light scattering up in the atmosphere above populated areas.
And I guess the key insight there is it's not just losing the view, it's wasted light, isn't it? Massive inefficiency.
Huge inefficiency. Then you got light trespass.
Okay, what's that?
Well, imagine light from, say, your neighbor's super bright security light flooding into your bedroom window.
Yeah, annoying.
Right, that's light falling exactly where it's not intended or needed. Light going where it shouldn't.
Makes perfect sense. What else is in the light pollution family?
Over-illumination is another big one. Just using way, way more light than you actually need for a task.
Like a completely empty parking lot lit up like it's daytime?
Precisely. And then we have clutter.
Clutter. That sounds like a visual mess.
It is. It's those sort of jumbled, confusing, often excessive groupings of light sources. Think of a street just crammed with flashing signs and super bright billboards all screaming for your attention.
Right, sensory overload.
Totally. And finally, there's glare.
Ah, glare. I know that one. That sort of uncomfortable, sometimes even blinding brightness, like when an oncoming car's high beams hit you square on.
Exactly that.
Yeah.
It's excessive brightness that causes real visual discomfort and can even be dangerous in some situations.
So all these different forms, they kind of combine to create this overall problem in our cities.
That's the picture, yes.
So where is all this excess light actually coming from? What are the main culprits behind it all?
Well, the primary cause, fundamentally, is just using artificial light inefficiently or, frankly, excessively. It really boils down to how we design, install, and operate our lighting.
Okay.
A major source is just badly designed lighting fixtures. Those old-fashioned street lights that just blast light upwards and sideways instead of pointing it down where it's actually needed.
I've seen those, yeah. They definitely contribute to that sky glow we were just talking about. What else is a big factor?
Overlighting. Just generally,
Hmm.
we often light up areas way more intensely than it is necessary.
Mm-hmm.
And then there are the street lights that aren't dark sky friendly. The unshielded ones are the worst offenders, sending a huge amount of light straight up.
Instead of down onto the street or pavement.
Exactly. And you've also got artificial lighting from places like greenhouses,
Mm-hmm.
industrial facilities. They often run all night. And surprisingly, even reflections from satellites can add a tiny bit to the mix.
Satellites. Really? That's one I wouldn't have thought of.
Yeah.
It's a smaller factor, but it's there. And then there's the big shift towards high-intensity LED lights.
Ah, LEDs. But aren't they supposed to be energy efficient, better for the environment?
They are energy efficient, that's true, but there's a catch. They can be extremely bright, and crucially, many emit a lot of blue-rich light.
And why is blue light a problem?
Blue light scatters much more easily in the atmosphere than other colors. So paradoxically, while saving energy, these bright blue-rich LEDs can actually make light pollution, especially sky glow, worse if they're not properly shielded and directed.
So the takeaway is that just switching to LEDs isn't automatically the answer. We need to be smart about how we use them.
Precisely. Smart deployment is key. It's about the right light in the right place at the right time.
Okay, so it's a bit of a trade-off then, efficiency versus pollution if we're not careful. What other factors are driving this increase in light?
Urban sprawl is a really big one. As our cities push outwards into previously dark rural areas, we naturally introduce more lighting.
New roads, new houses, new shopping centers, all needing lights, exactly. Then you have commercial buildings, office blocks, often left blazing all night, even when they're empty.
Mhm.
And let's not forget our own homes. Residential areas often have, well, quite excessive outdoor lighting, security lights, decorative lights.
Yeah, sometimes it feels like a competition.
It can seem that way. Add in overused roadway lighting, the explosion of bright digital screens like LED billboards, and just generally inefficient lighting practices because maybe the regulations aren't there or aren't enforced. It all adds up.
Wow. It sounds like a really complex web of causes, doesn't it? From individual choices right up to big city planning decisions.
It really is.
So, all this extra light, what's the big deal? I mean, beyond losing the stars, what are the actual effects of light pollution on, the world around us?
The consequences are actually pretty far-reaching. They significantly impact human health, wildlife, and the environment more broadly. Let's maybe start with ecosystems.
Okay.
Light pollution really throws a wrench in the works for the natural behaviors of many, many species.
How so? Give me some examples.
Well, take insects. They're often fatally attracted to artificial lights, right?
Yeah, moths around a porch light.
Exactly.
Yeah.
This disrupts their flight, their mating, their foraging. And since insects are crucial for things like pollination and form the base of many food webs, that has knock-on effects throughout the ecosystem.
Right. It's not just about the bugs themselves.
Not at all. Then think about birds, especially migratory birds. Bright city lights can completely disorient them at night.
Leading to collisions with buildings?
Yes, tragically common. Or it can cause them to circle aimlessly until they're exhausted. It can also interfere with their breeding cycles.
Wow. Okay. What else?
Sea turtles are another classic heartbreaking example. Hatchlings naturally use the brighter horizon over the ocean to find their way to the water.
But artificial lights on the coast confuse them.
Precisely. Bright coastal lights can draw them inland instead, towards roads or predators. It's often fatal. That image of the baby turtles going the wrong way, it really hits home, the unintended consequences.
It really does. What about mammals? Does it affect them too?
Oh, absolutely. Mammals like the Canadian lynx, for instance, rely on natural light cycles.
Mm.
Artificial light disrupts their circadian rhythms, their internal clocks.
It's affecting their hunting, sleep.
Hunting, sleep, reproduction, even the dynamics between predators and prey. Studies show some animals, like cougars, actually avoid light-polluted areas altogether.
Which could fragment their habitats, cut them off from parts of their range?
Exactly. Habitat fragmentation is a big issue. Even amphibians, frogs, salamanders, they can struggle with breeding and foraging because of artificial light, making them more vulnerable. It's like we're sending out all these confusing signals into the natural world without even realizing it sometimes.
It really is. Okay, so that's wildlife. What about the effects on us, on humans?
Well, our own bodies are also highly tuned to natural light cycles. Exposure to artificial light at night, especially that blue-rich light we talked about from LEDs and screens,
Mm-hmm.
it disrupts our own circadian rhythms. And that's linked to a whole host of problems. Sleep disorders, obviously, but also potentially depression, obesity, maybe even other chronic health issues.
How does it do that?
A key mechanism is the suppression of melatonin production. Melatonin is the hormone that tells our body it's time to sleep. Artificial light at night basically tricks our brain into thinking it's still daytime, so we don't produce enough melatonin.
And melatonin does more than just sleep.
Right. It's involved in regulating other bodily functions, and some research suggests it might play a protective role against certain diseases. So messing with it isn't great. It's not just about being annoyed by a bright light outside. It could be affecting our health quite fundamentally.
That's quite sobering.
Yeah.
And beyond the biological impacts, you mentioned the loss of the night sky.
Yes, that sky glow we talked about. It literally blots out the stars for most people living in or near cities. It diminishes something that's inspired humans for millennia.
And it must make life difficult for astronomers.
Extremely difficult. It severely hinders astronomical observations, making it harder and harder for scientists to study the universe from the ground. That's why dark sky reserves are becoming so important.
I can only imagine the frustration. And practically speaking, all this wasted light must have other consequences too, like energy.
Absolutely. Just think about all that light shining upwards or where it's not needed. That's just wasted energy, massive amounts of it.
Which means wasted money and unnecessary greenhouse gas emissions.
Exactly. It directly contributes to climate change. And one more thing, light pollution can even contribute to the urban heat island effect.
The UHI. How does light make cities hotter? That seems counterintuitive.
Well, two main ways. First, artificial lights themselves, especially older, less efficient types like high-intensity discharge lamps, actually emit a fair bit of heat directly into the environment.
Okay, direct heat emission.
Second, having all that light bathing the city at night can actually disrupt the natural cooling process. Surfaces that would normally radiate heat back out into space can't do it as effectively when they're constantly illuminated.
So it keeps the city warmer at night than it should be.
Right. Which leads to higher nighttime temperatures, increases the demand for air conditioning, which then pumps out more waste heat. It feeds into that whole UHI cycle.
Wow, I never really connected light pollution directly to urban heat like that before. It's clearly more significant than many of us probably realize.
It really is deeply intertwined with all sorts of other environmental issues.
Okay, so the effects are clearly significant. This begs the question, how do we actually know how bad the problem is? How do we measure and quantify something as, well, diffuse as light pollution?
Good question. There are several methods. On the ground, people use handheld devices called sky quality meters, or SQMs,
Yeah.
to measure the brightness of the night sky at a specific point. There's also something called the Bortle scale, which is more of a qualitative assessment. You basically compare what you can see in the sky, like certain faint stars or the Milky Way, to a 9-level scale.
More observational.
Right. But forgetting the bigger picture, across whole cities or regions, that's where remote sensing really comes in.
Satellite imagery.
Exactly. Satellites equipped with specialized sensors can measure the intensity and map the distribution of artificial light across vast areas. And complementing that, you can use photographic evidence, just pictures taken from the ground or airplanes, to visually document the extent of light pollution.
So it's a mix of ground-based and remote methods. Let's focus on the remote sensing part, as that's our main topic today. How exactly does that work, using satellites and maybe aerial tools?
Well, satellite imagery is definitely key here. Sensors like the VIRS-DNB, that stands for Visible Infrared Imaging Radiometer Suite day-night band, are specifically designed for this.
Day-night band, okay.
Yeah, it's incredibly sensitive and can capture even faint nighttime light emissions, things like city lights, boat lights, even wildfires. It measures light in the visible and near-infrared parts of the spectrum.
So it sees the light directly.
It does. And NASA has even developed processed data sets from this, like their Black Marble product suite. This refines the raw data by correcting for things that can interfere, like atmospheric haze, clouds, moonlight, even the angle the satellite is looking from. It gives us a much cleaner picture of the light coming from the ground.
That sounds pretty sophisticated. So satellites give us this really broad view. What about using planes or drones? Aerial photography.
Aerial platforms can provide much higher resolution images. Think drones or airplanes flying over a city at night.
Getting much closer.
Exactly. That lets us see really fine details, like identifying individual streetlights or specific buildings that are major light sources. It gives you that ground-level detail the satellites might miss.
Okay. And you mentioned ground sensors, too.
Right? Complementing the view from above, you can have networks of ground-based sensors, like those SQMs or illuminance meters, placed strategically across a city. They provide continuous, real-time measurements at specific locations.
So it's like a multi-layered approach. Satellites for the big picture, aerial for detail, ground for continuous local data.
That's a great way to put it. Each method gives us a different perspective and level of detail, and using them together gives us the most complete understanding.
So what are the really big advantages of using remote sensing, especially the satellite stuff, compared to just relying on those ground measurements?
The advantages are pretty substantial. First, obviously, is the wide area coverage. Satellites give you that synoptic view. They can see entire cities, regions, even countries, all in one go.
Seeing the forest for the trees, so to speak.
Exactly. You can see the large-scale patterns of light pollution that would be almost impossible to map out just by walking around with an SQM.
Right. What else makes it so valuable?
Efficiency and objectivity. Remote sensing eliminates the potential for observer bias that you might get with manual measurements. It's systematic, consistent across large areas.
More reliable data.
Generally, yes. Plus, modern sensors provide incredibly high-resolution imagery now. We can often pinpoint specific sources or types of lighting, which is really useful for understanding what is causing the pollution in a particular area.
And can we track changes over time?
That's another huge benefit. Satellites collect data repeatedly over the same areas for years, even decades. This gives us invaluable temporal data. We can monitor trends, see if light pollution is increasing or decreasing, and maybe even evaluate whether mitigation efforts are actually working.
So we can actually see if policies are making a difference on the ground year after year. That's powerful.
It really is. It turns it from a static snapshot into a dynamic picture.
But it can't be perfect, right? Are there limitations or downsides to relying on remote sensing for this?
Oh, definitely. No tool is perfect.
Right.
Spatial resolution can still be a factor even with improvements, meaning the satellite image pixels might still be too large to capture very fine details in really dense urban areas, or to distinguish between closely spaced small light sources. Older sensors, like the DMSP-ALL system used before VIRS, had pixels several kilometers across, which really limited detailed urban analysis.
So some very localized issues might get missed in the bigger picture,
Potentially, yes. Another major challenge is dealing with atmospheric effects.
like clouds.
Clouds are the big one, yeah. They can completely block the satellite's view of the ground. But even things like aerosols, dust, pollution particles, or just high humidity can scatter the light on its way up to the satellite, affecting the accuracy of the measurements,
So the weather needs to cooperate.
pretty much. And then there's the calibration of the instruments themselves. The sensors on the satellites need to be carefully calibrated and monitored over time to make sure the data they're sending back is consistent and reliable. Sensor performance can drift.
Right. You need to trust the measurements.
Absolutely. And finally, sometimes just accessing the data can be a hurdle. High-resolution commercial satellite imagery can be expensive, and processing and analyzing this kind of complex data requires specific technical expertise and software, which isn't always readily available everywhere.
Okay, so it's a fantastic tool, but we need to be aware of the challenges: resolution, atmosphere, calibration, access.
Exactly. It requires careful work and interpretation.
Now, you mentioned using Landsat imagery earlier. I usually think of Landsat for looking at things like forests or crops during the day. How can it possibly help us monitor light pollution at night?
That's a great point. Landsat doesn't directly measure visible nighttime light like VIRS does, but it has thermal infrared sensors, TIRs, which measure heat or thermal emissions coming from the Earth's surface.
Okay, so it measures heat. How does that relate to light?
Well, the idea is to use these thermal emissions as a proxy for artificial light, particularly in urban areas. The assumption is that areas with a lot of human activity, infrastructure, and yes, artificial lighting will often also show up as being warmer at night compared to surrounding natural areas.
So more lights, more activity, more heat.
That's the general correlation we look for in urban settings. We take the thermal data, usually from Landsat's band 10, convert the raw satellite readings into radiance, and then use physics equations, like Planck's law, to calculate the brightness temperature of the surface in Kelvin.
Okay, so you get a heat map, essentially.
Pretty much. And then to make it easier to compare different areas or the same area over time, we often normalize these temperature values to a standard scale, say 0 to 1, where 1 represents the hottest areas in the image.
So the resulting map shows thermal hotspots, which you infer might correspond to areas with high light pollution.
In many urban contexts, yes, it's an indirect method, but it can give us useful insights, especially when combined with other data or when looking at long-term trends where direct light data might not be available.
And has this approach been used in practice, like in that Colombo example you mentioned?
Yes, exactly. This thermal proxy method was used to look at light pollution trends in the Colombo Municipal Council area in Sri Lanka. They used Landsat 8 thermal data from 2014, 2019, and 2024.
And what did they find?
The analysis showed a pretty clear increasing trend in these thermally inferred bright areas, suggesting an increase in light pollution over that decade. The increase was particularly noticeable spreading from the coastline inwards towards the central parts of the city, the urban core.
Right. And what were the likely drivers behind this increase in Colombo?
It seems to be a combination of factors, all related to development. Rapid urbanization is a big one. The city grew, the population increased.
More people, more buildings, more lights.
Exactly. There was significant commercial and residential development. Plus, major infrastructure projects like new highways, the port expansion, and the big Colombo Port City development. All these turned Colombo into a major hub, get lots of new lighting.
Any other factors?
Yeah, interestingly, the study suggested that the continued reliance on older, less efficient lighting tech, like sodium vapor lamps in some areas, might also be playing a role, as they tend to scatter light more. Plus, just increased vehicle traffic, a growing nightlife and tourism scene. It all adds up to more light.
So it's a perfect storm of urban growth, infrastructure, maybe older tech, and lifestyle changes.
And did this thermal increase match up with the physical growth of the city?
It did, yeah. They also looked at land use maps derived from the same Landsat data. These maps showed a significant expansion of built-up areas, usually shown in brown on those maps between 2014 and 2024.
Especially along the coast and then the center, precisely where the thermal hotspots were increasing. So the expansion of the urban footprint seems to directly correlate with the increase in these thermal emissions, supporting the idea that it's linked to increased artificial lighting associated with that development.
That paints a pretty convincing picture, even using an indirect method like thermal data.
It does. It shows how urban growth can directly fuel this kind of pollution.
Okay, so that was Landsat using heat as a proxy. Now, you also mentioned using the VIRS DNB data for Colombo, which directly measures the light itself. How did that perspective compare? What did it show?
Right, the VIRS day-night band gives us that direct measurement of nighttime light intensity. For Colombo, we used NOAA's monthly cloud-free composite dataset, basically, monthly averages with the clouds already removed for the same years, 2014, 2019, and 2024.
Process using Google Earth Engine, you said?
Yes, GEE is a fantastic platform for handling these large satellite datasets. We visualize the VIRS radiance data using a color scale dark blue for low light, ramping up through greens and yellows to bright yellow for the highest intensity areas.
So a direct map of light intensity. What did that reveal about the changes in Colombo over that decade?
It really confirmed and added detail to the Landsat findings. In 2014, the brightest lights were clearly concentrated in the city center and around the port area.
The established core.
Exactly. By 2019, you could see a definite expansion of these bright zones outwards from the core, clearly indicating urban growth and the spread of lighting.
And by 2024?
That trend continued. There was further intensification of light in those central urban locations, probably reflecting new construction and denser lighting. But we also started seeing some new, isolated bright spots appearing in the more peripheral areas.
Suggesting new developments popping up.
Could be new residential developments, industrial parks, maybe large infrastructure projects taking shape on the outskirts. Conversely, the maps consistently show darker areas corresponding to known green spaces, water bodies, or maybe lower density suburbs with less lighting.
So the VIRS data really lets you see the spatial spread and intensification over time.
Absolutely. It gives you a very clear visual narrative of how light pollution is evolving across the city, supporting the trends we inferred from the thermal data, but with that direct light measurement.
It's clear that remote sensing, whether thermal or direct light, gives us incredibly valuable insights. So the big question then becomes, how can we actually use this information? How can it help us develop strategies to actually reduce light pollution?
That's where this data gets really powerful, moving from observation to action. Remote sensing data is proving super useful for developing targeted mitigation strategies.
Okay, how?
One key application is identifying hotspots. By analyzing the satellite data, city planners or environmental agencies can pinpoint the specific neighborhoods or zones with the absolute highest levels of light pollution, like city centers, industrial areas, maybe large transport hubs.
And once you know where the worst problems are,
You can focus your efforts there. Implement better lighting design, maybe mandate shielded fixtures that only point light down, or install smart lighting systems that can dim the lights late at night when there's less activity. It allows for targeted interventions instead of a scattergut approach.
makes sense. Focus resources where they're needed most. What other practical uses are there?
We could also use the data to evaluate different lighting practices. Imagine comparing a district that switched to well-shielded, warmer color temperature LEDs with one still using old, unshielded lights.
You could see the difference in the satellite data?
Potentially, yes. You could objectively assess which approaches are actually succeeding in reducing light spill and sky glow. This kind of data-driven evidence is gold for informing future policies on lighting standards for the whole city or region.
Great, moving beyond guesswork.
Exactly. And it helps in building the case for regulations. The remote sensing data gives policymakers a really accurate, comprehensive picture of the current situation. This helps them draft lighting ordinances that are effective and tailored to the community's needs.
Like rules about fixture types, brightness levels, maybe even curfews.
All of those things. Rules about shielding, limits on lumens, maybe restricting upward light, setting curfews for decorative or advertising lighting in certain areas. And perhaps most importantly, the ongoing nature of satellite data collection is crucial.
For monitoring.
Yes, for monitoring the long-term effectiveness of any strategies you put in place. Did that new ordinance actually reduce light pollution in the target area? Are things getting better or worse over time? The data lets you track progress and adjust your approach if needed.
So it's a whole cycle.
Yeah.
Identify the problem, take action, monitor the results, refine the action.
That's the ideal loop, yes. using data to guide the entire process.
Okay, now we touched on the urban heat island effect earlier and this link between light and heat. How can remote sensing specifically help us understand and maybe even tackle that connection?
Right. The UHI affects cities being hotter than their surroundings. We know the main drivers are things like dark surfaces absorbing heat, lack of cooling vegetation, waste heat from buildings, and traffic.
But light pollution adds to it.
It does, in those ways we discussed. Direct heat from inefficient lights, disrupting nighttime cooling, and the energy consumption link. Remote sensing, particularly Landsat's thermal data, is fantastic for mapping the UHI itself.
Creating those heat maps we talked about.
Exactly. By looking at land surface temperatures derived from Landsat, we can create detailed maps showing exactly where the heat island is most intense within a city, typically using that color scale, blue for cooler, red for hotter.
And looking back at Colombo, what did those UHI maps show over time?
They clearly showed the UHI intensifying between 2014 and 2024, particularly in those highly built-up central areas like Fort and Petta. More development, less green space, more heat gets trapped.
Could you even see the impact of specific projects like that Port City development?
Yes, that was quite interesting. In 2019, when Port City was mostly under construction, it appeared relatively cooler on the thermal maps. But by 2024, with more buildings, roads, and infrastructure in place,
It showed up as a hotter area.
it showed a significantly higher UHI intensity. It really highlights how converting natural or semi-natural surfaces to artificial ones traps more heat. Conversely, areas in Colombo with more parks and wetlands consistently showed up as cooler pockets.
Underscoring the importance of green spaces for cooling cities.
Absolutely. This kind of spatial analysis really drives home the need for strategic urban planning that intentionally incorporates green infrastructure, parks, trees, water bodies to help counteract these heating effects.
It's amazing how these different satellite datasets can paint such a detailed picture. Now, you mentioned some case studies looking at reducing UHI by tackling light pollution as well. What did they find?
Yeah, there have been some interesting studies. One in Bangladesh looked directly at the link between artificial light at night and air temperature.
Yeah.
They found a pretty strong correlation suggesting that nighttime illumination might contribute to around half of the urban-rural temperature difference in their study areas. Basically, excessive light helps keep the city warm at night.
So their proposed solutions targeted both.
Exactly. They recommended things like using more energy-efficient lighting, ensuring fixtures are properly shielded to point downwards, and implementing smart lighting that dims when not needed, things that reduce both wasted light and unnecessary heat generation and energy use.
Makes sense. And you also mentioned cool pavements. That sounds intriguing.
It is. Cool pavements are basically paving materials for roads, parking lots, sidewalks that are designed to reflect more sunlight and absorb less heat than traditional dark asphalt.
So they stay cooler during the day.
Significantly cooler. Research has shown they can substantially lower surface temperatures, which in turn can help lower the surrounding air temperature and reduce the overall UHI effect.
Any other benefits?
Yes. Studies suggest widespread use could reduce the need for air conditioning in nearby buildings, saving energy and cutting greenhouse gas emissions. Combining them with trees or other shade elements boosts the cooling effect even more.
And how do cool pavements connect back to light pollution?
Ah, that's a really interesting side benefit. Because they are more reflective than dark asphalt, cool pavements can actually increase nighttime visibility by reflecting existing light from streetlights or car headlights more effectively.
Meaning you might not need as much artificial light to achieve the same level of visibility.
Precisely. Some estimates suggest you could potentially reduce the intensity of street lighting by 30% or even more in areas with cool pavements without compromising safety. So it tackles heat and potentially reduces light pollution and energy use.
That's a win-win-win. Our city's actually doing this.
Some are, yes. Cities like Los Angeles, Phoenix, Davis, and California have pilot programs or are incorporating cool pavements into their infrastructure plans. Italy even has a national standard mandating them for public parking lots. It's a growing area of interest.
Fascinating. A material solution that helps with both heat and light. Okay, finally, let's tie this back to urban sprawl, which you mentioned as a driver of light pollution earlier. Can you elaborate on that connection?
Sure. Urban sprawl, that pattern of low-density development spreading outwards, often relying heavily on cars, inherently fuels the demand for artificial lighting.
How so?
Well, as cities expand, you need more roads, bigger parking lots, more commercial centers further out, all requiring extensive lighting. Low-density housing also often means more individual properties, each potentially adding its own outdoor security or decorative lights.
More lights per person almost?
Kind of, yeah. Plus, the 24/7 lifestyle often associated with sprawled areas means more businesses stay lit up late into the night. It's a pretty direct relationship. More sprawl generally leads to more artificial light being switched on across a wider area.
And can we actually see this pattern playing out when we look at the light pollution maps from satellites, like the ones for Sri Lanka you analyzed?
Absolutely. Those VIRS maps of Sri Lanka from 2014 to 2024 are quite revealing. The most dramatic increase in light pollution is undeniably around Colombo in the west.
Mirroring its rapid urbanization and infrastructure boom.
Exactly. But this sprawl comes at a cost, impacting nearby ecosystems like important wetlands, fragmenting habitats. We also saw a noticeable, though more gradual, increase in light along the southern coast, around Gali and Hambantota.
Again, linked to infrastructure and city growth.
Seems likely, yeah. And that's concerning for coastal ecosystems there, like the sea turtle nesting sites in nearby national parks like Bindala.
Any other areas stand out?
The area around Kandy in the Central Hills showed a marked increase between 2019 and 2024. That suggests urbanization is pushing into the surrounding forests and hill country, which could disturb wildlife in sensitive areas like the Knuckles Mountain Range or Utawatakala Sanctuary.
Even in the north?
Even in the north, around Jaffna, there's variation, but generally increasing light, likely reflecting post-war redevelopment and a shift towards more urbanized patterns. The overall picture across Sri Lanka really reinforces that connection. Urban sprawl seems directly proportional to increasing light pollution.
And this contributes to those broader issues like biodiversity loss, habitat fragmentation, increased energy use.
All of those, yes. The satellite view provides a stark visual reminder of how our development patterns are reshaping the nighttime environment, often in ways we don't fully appreciate.
Indeed. It really drives home that light pollution isn't just this isolated technical problem, is it? It's deeply woven into how we build our cities and live our lives.
Exactly. It's a truly multifaceted issue with these significant ripple effects on our health, on wildlife, on entire ecosystems, on our connection to the cosmos, our energy consumption, even the temperature of our cities.
And as we've really dug into today, these remote sensing technologies, satellites like VIRS and Landsat, aerial imagery, they're proving to be absolutely indispensable tools, not just for monitoring and analyzing this complex problem, but for giving us the hard data we need to make smarter decisions and actually develop effective solutions.
Precisely. And while we have to acknowledge the limitations, the atmospheric effects, resolution issues, calibration needs remote sensing's unique ability to provide that wide area, objective, long-term view. It's just essential.
Yeah.
It's helping us understand light pollution and its impacts in ways we couldn't before, as that Colombo case study really illustrated.
So there's a real urgency then to adopt more comprehensive strategies to mitigate light pollution.
There is.
And remote sensing is key to making those strategies work, helping target interventions.
Absolutely. Using the data to pinpoint hotspots, promote better lighting design, shielded, warmer color, right intensity informed smart regulations, encourage new tech like cool pavements where appropriate.
And crucially, to keep monitoring to see if what we're doing is actually making a difference over time.
That follow-through is vital. We need to track the effectiveness of these strategies using ongoing remote sensing data to ensure we're making real progress and adjust course if needed. It's all connected, isn't it?
It really seems to be.
Reducing light pollution isn't just about getting a better view of the stars, as nice as that is. It contributes to a better quality of life. Less energy waste, lower emissions, protecting biodiversity. It ties into those bigger sustainability goals we're all aiming for.
So perhaps as we all turn off our lights tonight, it's worth taking just a moment to consider the unseen consequences of the light we use every night, how our choices, even seemingly small ones made in the darkness, ripple outwards and impact the world around us. Thank you for this truly illuminating deep dive.
My pleasure. It's an important topic.